How to use PyTorch DataLoader for ML models. Are you curious about how to efficiently load data for your machine learning models using PyTorch? Let's break down the steps to make your model training smoother and more effective. First, you need to prepare a dataset. This dataset is essential as it provides access to your data samples and their corresponding labels or targets. PyTorch has built-in datasets like the Modified National Institute of Standards and Technology database or the Canadian Institute for Advanced Research dataset. If you have specific needs, you can create a custom dataset class. To do this, inherit from the TorchUtils data. Dataset class and implement the length and item retrieval methods. You can also include any necessary preprocessing or transformations, such as resizing images or normalizing data. Next, you will create a data loader. This is done by instantiating the TorchUtils DataLoader class. You will need to pass in your dataset object and set a few important parameters. The first parameter is the batch size, which determines how many samples will be processed together. A larger batch size can speed up training by allowing the model to process multiple samples at once, especially if you are using hardware like graphics processing units. Another parameter is shuffle. Setting this to true will randomize the order of your data at the start of each training epoch. This helps prevent your model from memorizing the sequence of data, which is important for better generalization. You should also consider the number of workers. This parameter specifies how many subprocesses will be used for loading data. Using multiple workers can significantly reduce the time spent waiting for data during training, making your workflow more efficient. Once you have your data loader set up, you can iterate over batches in your training loop. Each iteration will give you a batch of features and labels that you can feed into your model for training or evaluation. If your data samples are not uniform or need special handling, you can define a custom collate function. This function will specify how to merge individual samples into a batch, ensuring that your model receives the data in the right format. Practical applications of the data loader are vast. It is particularly useful for training deep learning models on large datasets, such as image classification tasks or natural language processing. By batching, shuffling, and parallel loading, the data loader optimizes the training process, making it faster and more scalable. In the context of artificial intelligence and machine learning, the data loader illustrates the importance of managing data efficiently. Tools like Chat Generative Pre-trained Transformer or DAL-E relying on large datasets and benefit from similar techniques during their training phases. Productivity plugins and frameworks that work with PyTorch often utilize the data loader to streamline model development. Using the PyTorch DataLoader simplifies the process of feeding data to machine learning models. It handles batching, shuffling, and parallel loading, which are essential for effective training. This ensures that your models learn from well-prepared and representative data, leading to better performance.